Afternoon, everybody. This is our March meeting of New Mexicans for Science and Reason. I'm Dave Thomas. Hope to have some more folks showing up here, but tonight's topic is the upcoming eclipse and past eclipses. So I got a little presentation together with some pictures of past eclipses, solar and lunar. And then being that I'm working up a paper on the flat Earth movement, I've got a video on how the flat earthers explain the eclipse and why they think eclipses are a problem for the globe. And then a couple slides about yesterday and today's equinox event. Okay, so here we go. Total solar eclipse season, April 8th and more. I have heard from a couple people that are heading out to the eclipse near Texas or along the path. I probably won't be able to, just being a caretaker is not compatible with dashing around the country right now. So, but I'll be observing it here. It won't be total, but it'll be pretty good. Not total though. I like to start things off with a thought of the day, and that is from Carl Sagan. The truth may be puzzling. It may take some work to grapple with. It may be counterintuitive. It may contradict deeply held prejudices. It may not be consonant with what we desperately want to be true, but our preferences do not determine what's true. Uh, sure enough. So, just trying to make sure. I'm going to stop sharing just a moment. We are recording. Okay, fair enough. Zoom really limits your ability to see what's going on sometimes. So this is from May 20th, 2012. I think at Steve Briggy's house. And we had a little CESE gathering, and there is my gadget, a binocular with the big end pointed toward the sun, and then a cardboard blocker. And you can project. You have to tighten up the focus, of course, but you can project a great little image. It works much better than a pinhole camera. To get an image that big, you'd have to have a pinhole camera bigger than a chimney, pretty large. So yeah, an inverted binocular is or monocular. It's a great way to observe that. There is a close-up of the eclipse in progress. Yeah, May 20th, 2012. And that was an annular eclipse. That's at the moment of annularity. I think somebody took this picture of shadows at that moment. I think that was Stewart. Yeah. So moving to August 2017, a great eclipse. Um, and so I got this little gadget together to explain it to the school kids down at Cottonwood Elementary. So basically, I've got a little styrofoam sphere representing the sun, and this orange hula hoop is the Earth's orbit around the sun. There's the Earth, and the pink ring is the moon's orbit. And I explained to the kiddos if this pink ring was in the same flat plane as the orange ring, then every single new moon would be a total eclipse of the sun somewhere on Earth, and every single full moon would be a lunar eclipse also. But this pink ring is tilted about 6 degrees, and that stays as the Earth orbits around the sun. That angle of that tilt stays constant. So it works out. There are like two big times a year when the line of nodes, the center of the ring there lines up with the sun. You might imagine if it was tilted in this direction, up away from the sun, then when the Earth got over here to 3 months later, then that those nodes would line up and there would be an eclipse. So, and you'll notice eclipses do come in waves about 6 months apart, and a lunar eclipse is often followed by a solar eclipse. In fact, for this next full moon on the 25th, there is a penumbral, pretty weak lunar eclipse coming up. So that's my physical orrery. This is a shot of the kids. Somebody had a neat little projector, similar to the one I showed you, but that one puts it up there where everybody can see it. If you have a colander, that makes little images of the eclipse. I've got a better one of that. There's the eclipse. We fought clouds that day. It was sort of an on and off cloudy day. You can see a partial eclipse right there. Um, this is my inverted binocular. That was a warm up. That's this fellow's telescope projected a nice version for all the kiddos. The clouds themselves could be a solar filter. So moving on to November 19th, 2021, and there was it was called the Beaver Moon Eclipse. They give these full moons whimsical names. Some astronomers frown on them. I don't mind. I don't put a whole lot of import on them. So here we are getting there, almost total. So for this one, I took my best picture of the eclipse, and then used the number of pixels of the image to scale up according to the diameter of the Earth. And so I said, what if something as big as the Earth was superimposed? Where would it line up? And it lines up with that shadow beautifully, which kind of indicates that maybe that shadow in the eclipse is the shadow of the Earth. And in fact, that was one of the first proofs of the round Earth, was the Greeks noticing, hey, that shadow is bigger and it's round, and what could be causing that? Maybe our planet is round. So there's the November 8th, the blood moon eclipse of 2022. And that one went total. This is before I learned how to get good pictures in dark conditions, but I've learned some since then. I did not make this one, but somebody took a montage and laid it out, and it shows beautifully the round Earth there. Here's another one showing the curvature of the Earth, and yet a third one. So those are nice. I did not do those. So the last fall, October, we had a nice annular eclipse come through, and uh, yeah, let me. I'm just gonna stop for a second and call up participants. Make sure, yeah, I can see that. Okay. Okay. So yeah, here was the path of this one. It went from west to east, as eclipses often do. And it went straight through Albuquerque. My hometown, Socorro, was off, but I traveled to Albuquerque to hang out at my sister's house, our treasurer, Debbie Thomas. Here is the colander trick, with not quite the totality, but each little hole in the colander is a pinhole. And the farther you are away from the pinhole, the bigger the image is. So here we're only a couple meters. The image is small. The ratio of the distance from colander to the shadow is related to the size of that image and related to the distance to the sun and the size of the sun itself. So that's a fun little thing. Here's my cousin Keith and my sister Debbie on the right and her friend Susan. And we all have our eclipse glasses there. These were the shadows during the totality of the annular eclipse. So these shadows cast by a tree several meters away are much larger than the shadows from the colander, but really nice. And these are taken by Carl Reinecke, one of our speakers last fall, and he is headed to the big eclipse in Texas. But he's done some excellent work, and I have his animated movie of the eclipse and time lapse. He's gonna do another one here. So I need to switch to the movie. So maybe that's it. No. Okay. So I got to stop for a second and find the movie. Okay. Okay. All righty. Here we go. Oh yeah. QuickTime player. Here we go. Yeah. So this is Carl Reinecke's time lapse of the October 2023 eclipse. And he lives in Placitas, which was right in the zone. Beautiful stuff. Sunspots pop right out. Excellent stuff. Okay. Uh-huh. Okay. So here is the upcoming eclipse. So yeah, a few of my friends have indicated they're going to head out. Um, anybody going? Marilyn, are you going or Joe? Anybody out there?
Yeah, I'm here. I don't think we're gonna make this one as much as we'd like to.
Yeah, I sure
We
would.
haven't planned for it. We saw the one up in Wyoming a few years ago, and
Oh,
this
that's
one
great.
just my son wants to go, so maybe we'll figure out a way.
To send one
Are
person.
you guys going?
I had hoped to go, but it's just too hard with taking care of Pam and she's still
Yeah,
wrapping up her chemo. She's doing better, but still going on. So it's not a
yeah,
time to be traipsing around the country. So
yeah,
I had planned to go, but I'm having cataract eye surgery on the 1st and the 3rd of April. So, and
that
I have to be here to have the eyes checked later, so I'll miss it.
you won't be looking at too much, it sounds like, during that time. Well, that's the way it goes. Alrighty. So but I have some more stuff here. So I've got another video how the solar eclipse proves the flat Earth. You guys ready for this? Here we go.
Uh-huh.
okay.
Okay, can I just open it from here? Yeah, right there.
So why didn't I flinch? Because the laws of science differ fundamentally from those of...
That was rude. Neil is not liked by flat earthers. Neil deGrasse Tyson. Get on with it already. Animations are not always to scale. Rotate in here. Don't see the problem. Earth is in nighttime. Earth spinning in the wrong direction. Next. Because they're showing you the eclipse, not got the answer for this, so stay tuned. That's all. Left. Wow. Don't know what Luke has to do with it. Okay. Um, yeah, wow. So so here's a little more. I've got the explanation for the why it's going west to east, but a couple more flat Earth memes first. The sun and moon are up there. How can the three be in alignment? We're down here. So I guess that's if you think the Earth is flat, then you would think the sun and the moon would be up there, and Earth couldn't be in the way. So this one shows the standard diagram of an eclipse with the umbra and the penumbra, and it's similar to a satanic symbol. So this is trying to make out that basically the NASA explanation of penumbra and umbra is a satanic symbol. It's secret code for the believers. Wow. So here's another one. Every lunar cycle should have a solar eclipse at the 2 days of conjunction. That's what I was explaining to the kiddos with the little homemade orrery there. So because the moon's orbit is tilted, you don't have an eclipse every new moon. So wakey, no. Eclipses are man-made? No. Why does the eclipse move west to east? This one on the left, science says the sun's rays reach Earth parallel, except on an eclipse when they're not parallel. And truth is that the sun is so far from the Earth, this is not to scale. If you drew this to scale, yeah, those lines would be very close to parallel. Not exactly. The sun is bigger than both the Earth and the moon. So, and that's why there is an umbra and a penumbra. And the size of the moon's shadow depends on the size of the moon and how far it is from the Earth. Shadows can't be smaller than the object casting it. Sure they can if the light source is bigger than the object casting it. And here, how is the moon casting 100-mile wide shadow? But if you actually look at the geometry and look at the diameter of that shadow with the proper diameter of the Earth, the moon, and the distance from Earth to moon, and the diameter of the sun and its distance, put all those things together, yeah, about 100-mile wide is correct. So mainstream eclipse fail, that's the claim. This is the 2017 again. So here is my explanation. I've got two animations for this first one. The moon is in orbit around the Earth. We don't care what the Earth is doing. We're just looking at the Earth is just sitting there, and the moon is orbiting, and it does that every 29 days about. It's got about a 240,000 mile orbit. So the velocity 2 pi r over t works out to about 2,200 miles an hour as the moon orbits the Earth. So 2,200 miles per hour. Not bad. And okay, so this next one, uh-oh. So, oh, oh no. So I'm missing one. So how did that happen? Uh, There we are. For only moon. So I got to the okay. Um, I think I have another copy. Okay, Eclipse B. Okay, are you guys oh, okay. Copy from there. Paste into there. Oh no. Um, oh, this is bad. Maybe I can just drag it. Okay, Firefox will show it. Darn it, guys. Sorry. Um, GIF. Okay. There it is. Yeah, here we go. So this is the second animation for this one. The moon is static, and we're just concerned about the Earth, and the Earth rotates from west to east, and that makes the sun rise in the east and set in the west. And so here we have three cities from the 2017 eclipse, so South Carolina states rather, Kansas and Oregon. And so this repeating animation just shows as the Earth spins around at about 1,000 miles an hour. It's a little less because of the latitude being less than that of the equator. But it's still, pretty good, a little less than 1,000. And we can see that shadow of the moon would race across America from the east to west, just like the sunrise. But it's only 1,000 miles an hour. So getting back to PowerPoint. Okay. So for the moon, the shadow is going east at 2,200 miles an hour. But if we're only looking at the Earth, that shadow is moving west at 1,000 miles an hour, same as the sun rising in the east. And when you put those two together, the motion toward the east wins. 2,200 beats the 1,000 miles an hour. And so the shadow goes from west to east. And those pictures, the comments in the video about Earth turning the wrong way. Earth was turning the wrong way because it was focused on the eclipse, not on the Earth as it would be viewed from the sun, for instance. So moving right along, if eclipses are real, why do you need special NASA glasses to see them? Throw away your NASA glasses, expose the lies, research flat Earth, and throw away the glasses. I think our former president did just that. The lunar eclipse happens at night. This is wild stuff. When it happens, the moon turns orange in color. This is caused when the sun and moon line up with the center of the disk Earth. The sunlight goes through the strong magnetic field of the North Pole, and the sunlight turns orange, and that light then hits the moon. Since the sunlight is orange, it makes the moon appear orange. The moon must be at the same altitude as the sun. It doesn't happen very often. It's a rare event. Holy cow. So they're trying to explain that the lunar eclipse, when you get that blood red moon, it's not the shadow of the Earth. The Earth is below both the sun and the moon. It's it's what happens to the sunlight when it goes through the highly magnetic North Pole region and gets orangified. Wow. Uh, so here's another one. When it comes to a lunar eclipse, is a physical object even needed to cast a shadow? And so they've got a bug depressing the water with its surface tensiony legs. And because the water acts as an excellent lens, you get these six lens apparitions on the bottom of the pool. So no, that's not how eclipses happen. Where's the giant wasp to step on our atmosphere to bend the light? So here's a good one from Young Earth Creationists, David Rivas Ministries, and they cranked up their exposure to where the corona was pretty overexposed, but then you can see there's the moon with the familiar Maria, the seas. So, and this is from the Young Earth Creationists laughing at the flat earthers saying, "Oh, you guys don't know science. You guys are pseudoscientists." But of course, these guys are wrong about evolution and the age of the Earth. But at least they got the shape of the Earth right, and they got that the moon is really what's making eclipses. We had a flat earther come to NMSR and explain eclipses, and he talked about Rahu and Ketu, these um, uh, Hindu deities. Very strange stuff. So here is a more professional picture with the probably a combination picture showing the features of the moon and the corona itself. Pretty amazing. So yesterday was the nominal vernal equinox at about 10 o'clock at night. That's when the sun crossed the from below the equator to above the equator in the sky, in the celestial sphere, which is fixed on Earth. So here's my little Python generation of what the Earth looked like this morning at dawn here in Socorro, New Mexico. And because the sun is above the equator on this day, the Earth is in between tilting away from the sun, northern hemisphere in the winter, and toward the sun in the summer. So we're right in between in March. And so all over the world, everybody, as the Earth turns, and there's the North Pole, South Pole, the Earth is turning um, about a vertical axis, and everybody all over the Earth experiences 12-hour days and 12-hour nights. And furthermore, the sun rises directly east. So this picture shows what it would look like from space, and sure enough, yeah, half the world is in night, and because the axis coincides with the lit up and dark sections, the whole world has 12-hour days. So this morning I went to Bullock Boulevard. I was located right here, looking east for the sunrise. And here's the picture. And Bullock does run east and west, and there at the pretty much eastern end of things is the rising sun. And also walk toward the sun a little bit. Bullock takes a turn, but right here, that portion is east and west, and it's parallel with my shadow. Another indication that the sunlight was coming from the east. This is the flat Earth explanation. So here's me and Socorro at sunrise on the flat Earth map, the polar map where the sun is at the North Pole, and Antarctica is this big ice wall that keeps all the oceans in. And Australia is horribly distorted, much wider than it is. Here's New Zealand out here. Um, and at the moment where it was sunrise here in Socorro, the sun would be directly above somebody just off the coast of Africa here. And uh, but the actual direction of east is this way, perpendicular to that radial from the North Pole. So the flat Earth explanation of where would the sun appear on the equinox is wrong. It's messed up. It says the sun is going to be much farther north than it should be. And there's here is my super simple formula for length of day for any latitude, theta, and any declination of the sun, delta. And you can estimate delta with this little sine formula using the equinox as the 80th day of the year, 360 degrees in a circle, 365 and a quarter days in a year. That gives you the angle of the sun. It's plus or minus 23 and a half degrees. Then you, whatever angle you've got. So for the equinox, the sun is 0 degrees. Declination is 0. It's right above the equator. That means that's a 0. Doesn't matter what the latitude is. That's a 0. Our cosine of 0 is 90. Times 2 is 180. Divided by 15 degrees per hour is 12 hours everywhere in the world. And so I made this chart here with Python that shows, this is using my super simple formula. This compares very well to charts that use much more rigorous measurements of day and night. But you can see from the equinox from March to September at the North Pole, it's always daytime. The sun is going to be much lower at the equinoxes. At the June solstice, the sun will actually be 23 degrees in the sky, but it'll be on the grazing the horizon on the equinoxes, but daytime for 6 months and nighttime on the South Pole. And you can see the as your latitude gets like 66, there is the midnight sun. You don't have any midnight sun below 66 north or above 66 south. And we see this great symmetry between the northern and southern hemispheres. So I was pretty pleased with that. And this is one of my challenges to the flat earthers is, hey, using a globe Earth, I was able to come up with this formula with a few equations. And here it is, simple formula, gives pretty decent results. It can be as far as a half hour off, but pretty decent. It explains why you can have very long days in northern Canada in the summer, and then very long days in New Zealand in the winter, our winter, their summer. So here's how the conundrum for the flat Earth. Here I've put our midnight at New Mexico midnight. The sun is on the other side of the world from us, basically. But on the flat Earth map, it's some 15,600 kilometers away from where the sun is, just above, just south of Sri Lanka, right above the equator. And how do we know this? Because when it's midnight in New Mexico, somebody in Sri Lanka would see the sun almost directly overhead at their zenith. So here's New Zealand, and say Wellington, New Zealand, and it's their sunset. So the flat Earth model says, hey, they're that's west, but they should be see the sun much farther north of west than it should be. So the flat Earth model does not explain what people in New Zealand would see. They should see, just like my sunrise was to the east, everyone's sunset is due west. Here in Socorro, we've got a big mountain in the way, so I don't really get very good pictures of that. But other people certainly could. And so here's the conundrum. It's farther from the sun to New Zealand, 17, almost 18,000 kilometers, than it is from the sun to New Mexico. So what is the flat Earth explanation for we've got light from the sun? How does it magically know to stop at the North Pole and not proceed to New Mexico when it is proceeding all the way to New Zealand, and that's even farther? How how does the sunlight know to form day and night? And there's no theory for it. So not only can the flat earthers not explain this graph that shows length of the day for the whole year for every single latitude on Earth pretty darn accurately, they can't even explain. I mean, there's the equinox. On the equinox, everybody has 12 hours. They can't even explain that one day, much less the whole rest of the year. So, generally, I found when I bring out math, flat earthers run away. So that's could be useful. Okay, so that is my presentation, and I'll stop sharing. All righty,
Very good, Dave.
thanks. Yeah, I'm learning all kinds of fun stuff. Had a fun time. We were watching a movie, but I banged out that script for the chart of length of day as for everywhere on the Earth. That was a fun one night project. Okay, so we do have a kind of different meeting coming up. One of my colleagues here at Tech is going to talk about basically how the philosophy of Eastern religion informs science and decision making. So it'll be a little different. Um, so that's next month, and then after that, I think Keith Gilbert is going to talk about his new book, and it's in the newsletter that just came out. So, so that's that. Thanks for coming, and we'll see everybody later, I hope.